Greetings, let's get some practice and go over a proof here, a linear algebra proof. So let's have V and W finitely generated vector spaces, and over field over F, and B consisting of V1 till Vn is V's basis, and then we have C is W's basis, and we have a linear map for F from V to W is a linear map. Then for any x in the vector space V, we have the following. F of x expressed in terms of C, so the image of F of the map, default map, its coordinates in respect to the basis C is equaling this basis in respect to in this matrix map, or this matrix representing a linear map in respect to bases B and C times the vector x in respect to B. So what is the proof of this? Let's go over it. Well, for any x in V, we have x is basically equal to x1 v1 plus until x and vn as a linear combination of these. And of course, in respect to the basis B, it applies also as well that f of x equals f of x1 times v1 plus all these terms until x and vn, which we can take out the x1 and also separate out by linearity because of it being a linear map. So we can rewrite this all as such. So as this. And we can also, because we have a theorem regarding coordinates, that f of x in respect to C is going to be expressible as this x1, a linear combination of the basis vectors of V under the linear map expressed in terms of C and put into a linear combination using these coefficients x1 till xn. So we would have until xn and f of vn in respect to C. And this, using matrix multiplication, we can write it as such. F of x in respect to C is purely equal to this matrix that consists of these column vectors, always f of v until f of v1 until f of vn, all in respect to C as a matrix, and all that multiplied by this column vector x1 till xn. Well, what we can now realize is that x1 till xn is equal to x in terms of basis B. And this thing is simply this matrix linear map for basis B and C. And so we get what it is supposed to be here.